Okay, so we were showing this. Was that on this? We were showing this is the gosh awful. Where's the key at now? What am I doing? Oh, there we go. So number 6 from yesterday's notes. Look at all of this ugly work, all the way down to that H being 4033 blah. Hey, check that answer. Remember that answer, 433. Okay, what kind of triangle is this? Yellow. No, what kind of triangle is it not? Not right. Hey, but what's this angle measure right here? How can I find that? 180 minus, right? Those are a straight angle. So can someone do that real quick? This is the time where you just look at me awkwardly and say no with your eyeballs. Huh? I can't think. So it's 130.8. You probably did that in your head, right? It's kind of easy. And then what's this angle up here? What's this angle right here? Well, it's 180 minus those other two. Can you give me what that one is? 14.7. We got to make sure we get this right. Okay, then did you hear me? Did you hear me? A law? What law can I do to maybe find this side? We'll call this side X. 19.7. You did it in your head? Oh, okay. So 19. So you did start messing with this. Like you wrote some things. Okay. All right. And then what law can I use? Anyone? 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 What law? There were two laws last year, the law of cosines and the law of the other one, sines. What law would I use when I have this angle in this side and I want to use this angle compared to that side? Was that law of sines or law of cosines? It was sines because it was so easy. It was just sine of 19.7 over 392 equals sine. Why would we not use this? Not judging. I would never do that with other teachers, right? Over x. Why would we not use this if we did this last year? Because the other way was like setting up a system using only SOHCAHTOA, and it just that's why it got so convoluted and lengthy. And I remember doing these questions back in regular CAT. It came out of our old CAT book, and we would do it before we did the law of sines and cosines and make the students go through all that. Then we teach the law of sines and cosines and show them how easy this question actually is. Okay, then crisscross multiply and you get x equals 392 times sine of 29.5 over, because this would be x times this, then you'd have to divide by that sine. Oop, it kind of made that look like a 5, and it certainly is not. Okay, you go ahead and beep, boop, beep, but don't tell me what the answer is. Because then when I go to this triangle, this is a right triangle. And now I have that x value, whatever it may be. And then I have 49.2, so I'll stick with that. What is this side compared to 49.2? The what side? Opposite. And what is this side that I just found on the previous question? Hypotenuse. What's opposite over hypotenuse? Sine. So I can now use sine 49.2 equals h over x, and I realize x is this. And then what would I do to solve for this? H equals whatever that x is times the sine of 49.2. Now you want to get real fancy, we can put this in no calculator format. We can just put times sine of 49.2, and then that would be the answer. You should get 433. That was on the other one. Anyone? Okay, got a head shake there. Look at this. Look at that. This is all the work that I need. Everything else is calculator compared to this, doink, this horrific, using a system of equations because I have two unknowns. And I know they put x down here. It doesn't really matter. All right. Choosing variables is irrelevant. Okay, now, this is kind of out of place. I just realized we were talking about the test, generating the test. What did I say? Didn't I say it's 2 weeks from yesterday? Or 2 days ago? It's after your 3-day weekend. Dun, dun, dun. Did I tell you that? I know I told one of the two classes. We don't care. It's going to happen in college. After 3-day weekends, you'll take tests. I tell you about my daughter? Remember she had a C in that one class? Okay, now it's time for the speech. You guys don't need it. I already gave the speech to A, Bers. Most of you don't. Mostly I see your faces in here. You've come the compass quite a bit on your own, but I still got to do my job. So why did I just come up with this? Because my daughter having a C in anatomy and physiology specific to her, I'm pointing at my neck because she's speech pathology, so it's mostly how speech presents itself in through anatomy, so on and so forth. She got a C in that. She has to have a B average in her main courses. So if she didn't get an A in another class to offset the C, she would have to retake the C. Luckily, this last semester, she worked her butt off. She had a B all the way through in this other class, got an A in the final, and this teacher gave her an A. So I think it was close enough, and she got the A. But she has like 1 or 2 more courses to go. If she gets a C in any one of those, I don't know how they're going to decide which one she has to retake. She might get a choice. So she's still got to go. So the whole point of retakes, yeah, they happen, but they happen at great cost. And that's what I'm trying to get you guys to understand. So if you do struggle, or if something in the homework was tough, and hopefully you determine that the night before. I hate how Compass, you can't sign up the day of. It's a bad system. I don't like it. But try to get that determined. And a lot of you guys know it. I see your faces in here. You come in and ask a couple questions and then move on with something else, right? That's all it takes. It's really simple. Back in the day, we used to have tutoring in the mornings, and I would have people like you come in every morning just to make sure, and then move on with something else. So just do that. I'm not an enabler. I don't sign you up. You don't know this. I don't sign people up against their will. I just don't believe in it. And I got yelled at for it. And I couldn't, anyone? Care less. I'm not an enabler. No one's pulling my daughter out of her dorm room by her ear to get an A in a course. She has to do it herself. So I'm sticking with that. I don't care if anyone disagrees with me. People, that's my right under the Constitution of the United States to have my beliefs, and I'm free to have. Isn't that true? Yes. Thank you. God bless. Oh, I can't say that. Now I'm in trouble. I said the G word. Someone's going to get offended. About to say bless America. Okay, 2 variables have a, can everyone say this word? Periodic. And I'm not going to fill in some of these sentences. We're going to do this later. So what did I start this off? We have a test in 2 weeks from Tuesday. This is out of place. I just realized we talked about the test Monday. I think it was Monday or Tuesday or Wednesday. And this is on there, but we're not going to do graphing yet of trig. It's more about evaluating that you did last year. Actually, it's going to be mostly review your test coming up. But anyway, we're going to do periodic relationships, then we're going to move on to SOHCAHTOA. trig in a unit circle. And then after that test, we're going to do graphing. So this is kind of out of place. Remember this 2 weeks from now. If the output values, that's weird. The output values demonstrate a repeating pattern. Here you go, over equal length. Anyone? Input intervals. We've used that sentence quite a bit when we were trying to determine if something was exponential, linear, quadratic, logarithmic. I was trying to think of some other ones. So what do you think? Does the first one represent a periodic relationship? Yes or no? 3, 2, 1, go. Yes. And actually, does anyone know what you're looking at here? What is this a picture of? Anyone? Someone knew this from playing around. This is sine. You might have guessed cosine. It's not. Actually, sine starts this way. I'll determine, I think later on there's a cosine graph somewhere. Why? These different colored intervals, these are repeating y intervals. Or y is repeating over and over again. Right? And then I could go backwards. I don't feel like getting the highlighter again. So this is a yes. Explain. It's because the y's are being repeated over equal length intervals of x's, or what the sentence is up here. Here's the explanation. Maybe you throw in some numbers. Well, there's no numbers located, but I guess you could say 1, 2, 3, 4, maybe, but there's no label there. So I don't even know if that's 4 units or not. You'll see later that this is actually 2 pi here. And then this is pi. And this is pi over 2. You're getting ahead of yourself, Mr. Samulus. But that's actually the parent. Well, not really the parent. This looks like it's up 3 units and down 3 units, but whatever. Getting too far. What about the next one? Yes or no? Just periodic? No. Periodic and pattern are 2 different things. These y's are not repeating. These y's are getting higher and higher and higher. In fact, the range of this is negative infinity to infinity if this pattern continues forward and backwards. Whereas this one, I'm sorry, range. Did I say period or I meant range if I didn't say that? The range here appears to be from 3 to -3, and that's it. Those keep repeating over and over again. So another way to say what's happening there. Okay, determine if each situation can be modeled periodically. What do you think of the first one? Think about it, and then tell me when I tell you to. You read it yourself. What do you think? Yes or no on the first one? Yeah, that's an absolute because let's think of a seat. You got a track here, and here's a seat. Your distance is here, here, here. This is your distance. This is your distance. This is your distance, and then you start repeating those distances. So it would be a nice little curve, kind of like the sine curve, maybe a little different. How about the second one in 10 seconds? 6, 5, 4, 3, 2, 1. What do you think? Yes or no? No way. One time you could lob it over and real lob shot, and the next one hit a laser. Anyone good at ping pong? No? No one that plays ping pong? Is there an app for that? Anyway, anyone play pool? Yeah, on your phone, right? You play pool on your phone. I know pool is on the phone. It's like no one plays real pool. Do you play real pool? Do you know the diamonds on the corner? This has nothing to do with these notes. Okay, there's a pool table. Do you know these diamonds? I don't know how many there are. That's geometry. You should actually watch Donald Duck in Math Magic Land. In Math, I actually own it. I don't know where it's at though. I think it's down in my basement. In Math Magic Land. It's actually an awesome video, and he plays pool in part of it, and then the guy explains the diamonds and how you use those to make bank shots. As long as you don't have any, what's that called? Spin. What was that called? When you hit the ball in a different way it's called a term. You said you play pool. All right. Anyway, let's move on. Next year, I'm gonna be like, why is this in the notes? What is this doing there? Okay, sketch the rest of the graph on the given axis. Oh, I didn't do that last. Okay, so 4, where does this end then? What do you think that is? 8. Okay, so that's at 8. So I have to go, well, it kind of cut me off here. But at 4 to 0, so 0 to 4, I have another 0, right? And then this is this chunk. And then this looks like at 6, comma, -3. So at -2, comma. So this would be this part right here, right? Kind of did that all right, right? I didn't even read this. I just went down to the bottom, and I didn't even fill out some of these last hour because I don't know what they're kind of saying. We're going to get into these things when we actually graph. So I think this is getting a little ahead of ourselves here, but I can do that. I can sketch the next parts. It looks like, and I guess I could go to -6, which would be the next high point, right? So I could at least do this, right? Correct? And then I could, okay, fine. I don't know how far they want me to go. This would be the next high point. All right. And then I think that's good enough. Because I kind of got cut off for the last one. This one I could do one full thing. So at -4, I'm at 4. Actually, at -4 or 2, that would be this part. So actually, this part comes here. So 3 is at 1. So 1 away here is this. This is this part, which mirrors this part, right? Got it? And then this part from 2 to 3 is this part from here to here. Getting a little scratchy there. And then 1 is at -3. And then this one goes here. And then just check, does that graph look like a carbon copy of the other one? And it does. Okay? So it's like cutting and pasting and moving it. A period's length is what you're going to find out. So the period of the function of this is the smallest change in x values it takes for the function to repeat itself. I don't know what this in fancy math terms we say. We just say, we're going to say this. For the above one, let's highlight this. And then, so this graph, this period is 8. So we really literally are going to say P equals 8. And what are the units? I don't know. Okay, they didn't mark that. For this graph, the period is 4. So this graph, the period is 4. Not sure what they're looking for in those fancy math terms. And then I don't know what this is. This is going to lead into domain issues, though. And we talk about domain and all that other stuff. You'll see the terminology that we need to use, and I'm going to wait for that. Okay, so look at the first one. 5 seconds. 4, 3. What is the period in 2, 1, 0? What's the period? 1/2. By the way, there's a cosine curve. It's actually an upside down cosine curve. Cosine starts at a higher low point. Sine starts in the middle point. Or it depends. You're going to have shifting right and left. So that could be a sine curve if we shifted it. So I just like mentioning these things. This one we better be careful. I would be better be careful in marking like the key. What? Marking the key points. And then this kind of stops. It doesn't get back up to that middle point. So I'm going to go up to here. That is a period. That shows all the unique y values, both the low ones and the high ones. So what's the period then? 3, 2, 1, go. It's the distance on the x-axis. It's 16. Okay, again, this is out of order. AP did this though. We tried to do the order of the AP lessons. This should be right before we graph sine and cosine. We're not doing that for 2 weeks. It's just kind of weird. So just try to remember this. I do like this next part. This is kind of cool-ish kind of questions to think about the past and the future. Okay, so first of all, find h of 18. Whoa, what does this only go to? From what to what? What does that only go to? From -5 to what? Input, say it. So I got to input 18 and get some sort of output. But the point of this is periodic. So I did this with the others. Where is 18? Between what and what in one of the intervals where a period is done. Okay, so it goes from 0 to 4. So where is 18 between? See if you understand my question. Between what and what, which would be another period? 16 and 20. So this is what I have my students do. Just visualize up here that this is 16 to 20 now, these two values. So then where is 18? What does it mirror? 1, 2, 3. 1, 2, or 3. It mirrors 2. This is where 18 would be right in the middle, right? Is that correct? I feel like I'm missing something here. 16, 17, 18, 19. I did wrong. I'm sorry. It's not 16. It's what? I knew I screwed up. So the period is 0 to 5. I screwed up. So sorry. What is it in between 15 and 20? I knew something was wrong there because I was off. And then I realized I saw that 4, but it actually ends at 5. My bad, dogs. Riff. You're new to all my little things. Anyway, 15, 16, 17, 18. So who does 18 mirror? 3. 3 comma -3. So 18 comma -3. See how you do that? These are fun little questions. Well, I find them fun. All right. So we can answer a couple of these right away. On which subintervals of -10 to 10 is h constant? Well, you know what? It's these. So I can answer those right now. And then you're supposed to really do this. You're supposed to use parentheses on where intervals are constant, increasing, or decreasing. The philosophy is after and before those points, there's a change. So you really shouldn't, there's a change in what it's doing, let's just say. And then union that, of course, I see from 4 to 5, right? No one would have a problem with that, correct? The future one is easy, probably. What would be the next one all the way up to 10? Nobody? What would be the interval? Think about it. If you're not doing anything, you're just going, okay? No thinking, no knowledge. Then you go to tutoring and say, I don't know how to do any of this. 9 to 10, right? Isn't that easy? Because it's just like cutting and pasting this. The next interval would be from 5 to 10. This would be 5 to 10 would be the next interval. Okay, I don't want to have to redraw it. You understand what I'm doing up there, right? I'm like marking the next x value for the next period would be. All right. And then you can either erase or cross them off for the next one. And then backwards, well, what would this interval be from what to what, where this would be again? Negative, anyone? Negative 10 to negative 5. So then what's this interval? Negative 6 to negative 5, right? Okay, that one's a little bit tougher because you got to think appropriately. And then feel free to cross them off or leave them or erase them. This is how you play the game so you don't have to keep graphing them. I mean, heck, I can ask what's h of 79? And then all you have to do is, okay, where's that interval? Oh, that'd be from 75 to 80. So h of 79 would be, what would be the answer? 3, right? That's all you got to do. Okay, does h have a positive, negative, or zero slope at 1? Well, here we go. Exactly the kind of question I'm talking about. 116? You expect me to graph this all the way out to 116? No. What's 116 between? What two interval numbers where the next thing happens? It's actually 115 to 120, right? So what does 116 emulate? 1. What kind of slope is that? What's that instantaneous rate of change there? Positive, negative, or 0? Negative. That's why we're asking that. Slope at that point means instantaneous rate of change at that point. Okay, all right. Oh, and I'll tell you that I struggled on this one and I didn't read. And actually, I'll tell you I didn't read this one at all. I didn't read it correctly. I'll be more than happy to admit my mistakes last hour. A lot of times I just scan the notes. Yeah, I know what I'm doing. This is easy. Then I come and I'm like, oh, wait, I didn't really read that one. And I didn't read this one correctly. Michael swims laps in a pool at a local rec center. The pool is 25 yards long, and it takes him about 21 seconds to get from one side to the other. My mistake last hour was I thought that was there and back. So my question then is, how long does it take to go there and back then? How many seconds? 42. That's this right here. That's 42, right? I put 21 there. And then what's this at y value up here? What's that y value up here? 25. And then understand, ready, set, go. He swims. And then notice he's increasing at an increasing rate, because what does a swimmer do? They start off at what speed? 0, and then they start going, right? And then they get a little bit faster. And then I guess the idea, although I think they kind of don't slow down when they get towards the other end, they actually kind of hit an abrupt stop, right? But they're kind of saying halfway through, then they're slowing down, they hit the wall, and then they come back the other way. All right, so you have concavity points here, right? Increasing at an increasing rate, decreasing at a decreasing rate, so on and so on and so forth. But anyway, find the coordinates of point B. What's the coordinates of point B then? Well, it's what's the input? What's the input value? 21 seconds. What's the output value? 25 feet away. So it should take 21 seconds to get to the other side. And that's what you can put for. I'm not writing. You guys are way better at writing. I'm not a writer. I hate writing sentences on the screen. Okay, but what does this mean in context of the question? It takes them 21 seconds to get to the other side in that first lap. Find the coordinates of D. What is that coordinate? What's the time on that? 84 seconds, 0 feet. That means you're back at the beginning and it took 81 seconds for 2 laps, maybe. There can't be anything wrong with that statement. Okay, this was interesting. At points A and C, it's 18.75. And then, you know what? Oh, I shouldn't do this. But I want to show you how I found the actual answer to this question. Here's what I did not read. Oh, no, I'm not on that yet. Sorry. At points A and C, Michael is 18.7 away from the south end of the pool. How many seconds have passed between point A and point C? What's your guess on that? So here we go. We're starting here. We hit there. We go to this side, and then we end up back where we started. How many seconds do you think that took? That's a period, but just starting and ending at a different point. So this is 42 seconds. Give a reason for your answer? I don't know. It's a period, but you just started it at a different position. So that's what a period is. How long does it take to go there and back and end up where you started? Well, we started at 18.75 away. We went to that side, went back to the other side, and then we ended up where we started. That's the idea of period there. Now, here's what I didn't read. What I didn't read, and I panicked, was approximate, not an exact answer. And then I had to read, what is this saying? Approximate the next time Michael is at point A that he is away from the south of the boat. Next time after Michael is at point A that he is 18.75. So from point A, when's the next time he is 18.75 away? Right here, right? That was the first thing I was reading. I was trying to understand what they were saying. So not point C. This is the next time right away that he's 18.75. Then I panicked because I was like, does that even look like 1/4 of the period? Yes or no? I would say no. So that kind of panicked. And I did do this. This was 21. And then I did do this. And I'm like, how am I supposed to get that? And I didn't read that thing there. Approximate. So what do you think a good approximation might be? Throw out a number. I said 30. All right, that's what I said. I said about 30 seconds, approximate. And then, do you want to know what I did do? You know what this is a picture of? This is a cosine graph. I actually, on my calculator, derived the equation from this picture. And then I put that in y1, and I put this in y2, and I found the intersection. The actual answer is 28 seconds. I'm not going to go through that with you. I was thinking, hey, maybe it would be fun if I showed you the equation. You'd be like blown away. But it is something in the future. You will find the equation of this. You will know how to do that. And it's actually not that hard. Believe me, it won't be. Callie, I taught a Callie last year. Anyone know Callie R? No? All right. Just tell her she's in the notes. All right. It says that since Michael swims 25 yards every 21 seconds, he must be swimming at a constant rate. True or false? Think about a swimmer. Is that true or false? No, literally at one point you're at 0 speed when you hit the wall and come back the other way, right? So you're definitely not, and that's these concavity points. You're increasing at a increasing rate, increasing at a decreasing rate. Does that say decreasing at an increase? That's weird. That's not really true. It's like that's a different context, but you're definitely not a constant swimmer there. Okay, let's move on. I feel like doing the video, I'm taking longer. Below is one cycle of period. Use the graph to answer these questions. You can read that up there. Is the function increasing, decreasing, or both on the interval 18 to 20? It's the same game. 0 to 4 is the period. From 18 to 20, what's a full cycle? What are the x values? Not 18 to 20, but what? And feel free to put them anywhere. Like just say, okay, this would be from 16 to 20. So here's where 18 is. What is happening from 18 to 20? Is it increasing, decreasing, or both? It's increasing. Then we got to do it again. 31 to 30. Ooh, this is a good one. Okay, where do we pick from 31 to 33? Hold on. So 0 to 4. Where is this around where I have an interval of the next cycle? It's not right perfect. 31 and 33 isn't perfect. So what are we going to pick? 32, right? So here's 32 to 36. So we might have to complete this graph a little bit and understand that 31 is right here, right? This is how we kind of cheat, so we're not going to graph this out to 32. We imagine this is what's going to happen at those intervals. Okay, then what's the concavity from 31 to 33? What's that concavity? What's that concavity? You're killing me. Down. It's a bowl shaping down. So it's definitely definitive. And then we got to do it one more time. Relative min, max, or neither at point 82. All right, got to think about this. 0 to 4. What's the interval where 82 falls between? 80 and 84, right? So what's happening at 82? What do you have? You have a minimum. This is how you do these things. Very simple. Got it? Paying attention? I don't get any of this. Oh, we done? Oh. Have a good day, everybody.